Hey there, awesome physics students. Let's talk about gauge pressure. The idea behind gauge pressure is quite simple. We live in a sea of air, and normally we experience atmospheric pressure around us all the time. The idea is if you had a gauge, that gauge should read 0 normally at atmospheric pressure. If the pressure is higher than atmospheric pressure, the gauge will be positive. If the pressure is lower than atmospheric pressure, the gauge will read a negative number. So gauge pressure is really just the amount of pressure above or below atmospheric pressure that we are. So you can write this down in this equation in this way. So the absolute pressure is just the atmospheric pressure plus the gauge pressure. So the idea again being that when the gauge reads 0, 0 plus atmospheric pressure means that the absolute pressure, wherever that's being measured, is the same as atmospheric pressure. If gauge pressure is negative, when you add atmospheric pressure to a negative number, then you will get something lower than atmospheric pressure, and the absolute pressure is below atmospheric pressure. And of course, if it's positive, then the absolute pressure is higher than atmospheric pressure. This should remind you of this equation that we talked about a few videos ago, where you had the pressure in some depth in a fluid was just equal to the pressure at the top of the fluid plus the increase in pressure because you are deeper in that fluid. This, as in our previous equation, was just rho GH. Now this rho GH term is useful if you're going to compute the number in pascals, but oftentimes we don't want to compute the number in pascals, and we just want to know in some units, maybe perhaps units of mercury, millimeters of mercury or something like that, the pressure difference. And so this is the amount of pressure below or above atmospheric pressure. So let's do an example to see how this works. Imagine you have a container of gas and you have a tube that you fill with mercury here. So there's mercury inside here, and the mercury goes up to a level that is 10 centimeters above the level of the gas over here. And then the depth on this side there's 20 centimeters of mercury here, which is 200 millimeters. Let me just draw the here's the gas. And so we want to know the pressure of the gas in gauge pressure. Okay, so how do we do this? Well, here this is exposed to the air right here. And so because it's exposed to the air, it's just 1 atmosphere of pressure on top. So that's the pressure on top is 1 atmosphere. And as we increase 10 centimeters or 100 millimeters, then the pressure is going to increase. The gauge pressure is going to increase. It's going to be higher than atmospheric pressure by 100 millimeters of mercury. And so as we continue to increase, then now the gauge pressure goes from 0 to 100 millimeters of mercury to 300 millimeters of mercury, right? That's 10 plus 20. And then as we move here, it doesn't increase. And now we're going to decrease our depth, and the pressure will decrease by 200 millimeters of mercury. So now the pressure here will be 10 centimeters of mercury, or 100 millimeters of mercury. Okay, so so that's how this gauge pressure works here. You may see this in real life in several different ways. And one, you might think of blood pressure. You may have seen this as like a typical blood pressure is 120 over 70. And these are in millimeters of mercury. So is this gauge pressure or absolute pressure? Well, you can ask yourself, if you poke someone's puncture their blood vessel, does air rush in or does blood come out? Of course, we know blood comes out. So the pressure must be higher inside than it is outside in the air. So this is gauge pressure here. This is the pressure above atmospheric pressure. If this instead were absolute pressure, 120 millimeters of mercury as absolute pressure would be below 1 atmosphere of pressure. And that would mean that if I poked a hole in my blood vessel, air would rush in because it's lower pressure in there than it is out here. But of course, that doesn't happen. Another scenario that you've probably seen before is if you measure the pressure in your tires. Let's say you measure your pressure in tires, in your car tires, and you measure them to be 35 psi. Is that a gauge pressure or absolute pressure? Well, one clue is that you measure it with a device that has a gauge on it, and so that strongly suggests it's gauge pressure. Your intuition would be correct. And one more sure way to know this is if the tire is completely flat, what does the gauge read? The gauge reads 0. But is it actually a vacuum in there? Is there no air at all inside the tire? Well, no, it's atmospheric pressure, right? So in that case, if it's 0 at atmospheric pressure, that means it's got to be gauge pressure. One last example. On the news you might see, or on the weather report, you might look at the pressure outside when they report the pressure, and they often report it in a form like this. They'll say 30.05 inches. Well, what does that mean? Well, first of all, you have to figure out, what does this inches mean? Inches of mercury. If you notice that it's inches of mercury, then you can compare it with atmospheric pressure. It's about equal, roughly, it's a little bit more than atmospheric pressure if it were atmospheric pressure. So this is likely to be atmospheric pressure just because it's a comparable number, and it just says that the pressure outside today is slightly higher than it is normally. If this were gauge pressure, that would be ridiculous. What that would mean is that the pressure has doubled overnight, and the atmospheric pressure is twice as much as it was yesterday, which is complete nonsense, right? So this is an absolute pressure, okay? Hopefully this gives you an idea of how to treat gauge pressure versus absolute pressure.